Another example. So here we have 3e to the x, 3e to the x minus 5x. Perfect. So how many terms do we have? Our first term, our second term. There we go. So let us take the integral of each of these. First of all, you have 3 as a coefficient. We can write 3 in front of the integral of e to the x minus 5x. And just let me separate these. Dx minus 5 integral of x dx. The integral of e to the x is e to the x plus constant of integration. So you have 3 times e to the x minus 5. The integral of x, it has exponent 1. So n is equal to 1. You get x to 1 plus 1 over 1 plus 1. One constant of integration for both of these integrals. So this is equal to 3 e to the x minus 5 halves x squared plus constant of integration. Very well. Next example for you. So in this example, we have integral of 7 over x dx. There you go. You can write this integral as 7 times 1 over x dx. 7 is just a coefficient. You can write 7 in front of your integral. 1 over x dx. The integral of 1 over x dx is defined as ln of absolute value of x plus constant of integration. So this is equal to 7 times ln of absolute value of x plus c. Next example for you. Integral of 6 times e to the x plus 4 over x minus 1 dx. So how many terms do we have? This is our first term. Then you have your second term. And your last term is just a constant. Your third term. The integral of 6 times e to the x can be written as 6 times the integral of e to the x dx plus 4 times the integral of 1 over x dx minus integral of dx. So this part is equal to 6. The integral of e to the x is e to the x plus 4 times the integral of dx over x is ln of absolute value of x, and the integral of dx is equal to x, so you have minus x plus constant of integration. Example for you. This example says, let f prime of x be given as, so the derivative of the function is given as 3x squared minus 4x plus 2. minus 4x plus 2. And you also know that f at 1 is equal to 4. What is your function? Very well. To find f of x, we need to take the integral of f prime of x. So the integral of f prime of x with respect to variable x, dx is equal to the integral. You copy down your derivative, 3x squared minus 4x plus 2 dx. How many terms do we have? 1, 2, 3 terms. The integral, which is equal to f of x, is equal to 3x squared 2 plus 1 divided by 2 plus 1 minus 4x raised to 1 plus 1 divided by 1 plus 1 plus 2 times x plus constant of integration. So f of x is equal to, you can cancel out 3 and 3, you get x to the third, and here 4 divided by 2 is 2x squared plus 2x plus c. You have another piece of information here. It says f at 1 is equal to 4. So take a look at this. F at 1 is equal to 1 cubed minus 2 times 1 squared plus 2 times 1 plus c. F of 1 is equal to 4, so 4 is equal to 1 minus 2 plus 2 plus c. Luckily for us, we have 2 minus 2, which is 0. If you subtract 1 from both sides, you get 4 minus 1 equals to c, or c is equal to 3. So let us get back to the function. Our function is equal to x cubed minus 2x squared plus 2x plus Very well, let us start 5.2. What if we have more complicated integrals? If we have more complicated integrals, we need to come up with other techniques to actually find the integral. Let me give you one example. What do I mean by more complicated integrals? 2. Take a look at this example. Suppose you have the integral of 12x plus 4 divided by, on the denominator we have 6x squared plus 4x plus 1 dx. We're going to introduce substitution method. Substitution. So how does this method work? In general, if you have functions of this form, if you have integral of something on the numerator, something on the denominator, dx, take a look at your denominator. So the denominator is your target. If you have integral of square root or nth root of a quantity, then your target is the quantity inside the radical. If you have the integral of e raised to an exponent, then your target is your exponent. So this is the thing that you have to look You have something on the numerator, something on the denominator. So your target is your denominator. Take a look at this case. We have some expression on the numerator, another expression on the denominator. Since it's a format of a quotient expression, we look at the denominator. So our denominator is equal to 6x squared plus 4x plus 1. Take the derivative of your denominator. It is 6 times 2 times x to 2 minus 1 plus 4. The derivative of 4x plus 1, the derivative of 1 is 0, and the derivative of 4x is 4. So the derivative of your denominator is 12x plus 4. And since you took the derivative with respect to variable x, you add dx next to it. Okay. Now take a look at your integral. Your denominator is a quadratic expression. The derivative of your denominator is a linear expression, which is on your numerator. So what we're going to do, we're going to say, hey, this is my u, and this is my du. Then you rewrite your integral using this substitution. Now your integral is the integral of du divided by this expression. We call this u a new variable. Remember that the derivative, the integral of dx over x is ln of absolute value of x plus c. It doesn't matter if you use a variable like t or u or w, anything. So dt over t is equal to ln of t. You can change this variable. It doesn't matter. If you have du over u, it is ln of absolute value of u plus constant of integration. So the integral of du over u is ln of absolute value of u plus constant of integration. But what is our u? Our u is 6x squared plus 4x plus 1. So let's substitute that right here. Ln of absolute value of 6x squared plus 4x plus 1 plus constant of integration. This method is called substitution method. Next example. So here we have the integral of x, where we have 6x divided by 3x squared plus 5 dx. Very well. As you can see, we have a quotient format. We look at the denominator. Our denominator is 3x squared plus 1. Suppose we assign a new variable u to this expression. Then we take the derivative, du, which is 6x. The derivative of 5 is 0. Since we took the derivative with respect to variable x, we add dx. Then we look at our integral. Our integral can be written in compact form 6x dx, which is du divided by u. Du divided by u, the integral is equal to ln of absolute value of u plus constant of integration, which is nothing but ln of absolute value of 3x squared plus 5 plus 6. So I expect you to ask, what if I don't see 6x on the numerator? Take a look at this example instead. So you have integral of x divided by 3x squared plus 5 dx. Okay, so since they have a quotient format, we look at the denominator, and u is equal to 3x squared plus 5. If we take the derivative, du is equal to 6x dx. I don't have 6 on my numerator. I only have x dx on my numerator. What I'm going to do, I'm going to multiply and divide by 6. Since it's just a number, I'm allowed to multiply and at the same time, don't forget to divide by a number, a constant, a coefficient. I'm not worried about this. It's not a variable. It's just a number. Now, I can take the whole thing on my numerator, and this is my du. On the denominator, I have my u. So now I can rewrite my integral as 1 over 6 integral du divided by u, which is 1 over 6 ln of absolute value of u plus constant of integration, and u is 3x squared plus 5. So I get 1 over 6 ln of absolute value of 3x squared plus 5 plus constant of integration. Another example for you. So here we have 3 to 3x plus 7 dx. We have e or an exponent or a base raised to an exponent. So here we have an exponent. We look at an exponential. 3x plus 7. So u is your power, is your exponent, which is 3x plus 7. du is 3 dx. I can rewrite my integral in this form. I can write the integral. I have 3 dx, which is my du. I have integral e to u d. So I rewrote my integral in a shorter and compact form that I know how to evaluate this integral. This is integral of e to u plus constant of integration. But what is u? U is 3x plus 7. So you get e raised to 3x plus 7 plus constant of integration using substitution method. Another example for you. We have integral of 4x e raised to 5x squared minus 2. 5x squared minus 2 dx. Very well. We have e raised to an exponent. We look at our exponent, 5x squared minus 2. So we say that, hey, let u be 5x squared minus 2. du, or the derivative of u, is 10x. The derivative of negative 2 is just 0 times dx. Okay. Do I have 10x dx in the integral? I don't have 10. What I have is 4. So what I'm going to do, I'm going to multiply and divide by 10. So I'm going to rewrite my integral this way. The integral of 4x e to 5x squared minus 2 dx. I'm going to multiply by 10, and at the same time, I'm going to divide by 10 to balance this operation. Now I have dx, 10x, which is my du. and the exponent is just u. So I'm rewriting my integral in the compact form, so it helps me to take the integral easier. So I have e raised to u du. I know how to take the integral. E to u is just e to u plus constant of integration. I have 4 over 10 eu plus c. But what is u? U is 5x squared minus 2. So I get 4 over 10 e raised to 5x squared minus 2 plus constant of integration. We can rewrite this as 0.4 e raised to 5x squared minus 2 plus constant of integration.